right. So let's take a look at the page 37 practice questions in your book. Are there any questions here, 37, 38, that you want me to go over specifically? Don't hesitate to ask. The answers are on the back, so I'm assuming that if you didn't get it, that's the one you'll ask, right?
I'd say either 39 or 40.
Page 39? Yeah, this one here. Okay, let's take a look at this one here, number 5. Okay, so when you look at a free body diagram, you kind of have to make a connection between the diagram and what is happening, okay? Be creative and picture the object actually moving. So you have this 5 kilogram mass, right? So that would be like 2 textbooks. You have your physics and chemistry textbooks right there that Nick has. That's about 5 kilograms. They're thick, right? And it's moving with a constant speed of 4 meters per second to the right. Okay, so you're looking for all these blanks in the FBD. All right, so is that labeled constant speed to the right? Okay, so this is going this way. So I'm gonna add something here. This is how it's moving. So it doesn't show you on the FBD here, but I like to label the net force in the direction of the motion or the potential motion. Now, if it tells you this is constant speed, what is that net force gonna be equal to? It's gonna be 0, remember? Yeah, no acceleration means no net force, F equals ma. All right, now it is useful, like I said before, to label that net force anyway, because this is gonna be your positive direction. Okay, your FBD then will have to be completed here. This will become your FAX, and then lifting it quite a little bit is FAY. That's also positive, that FAX. Friction is negative. Okay, so those are the first thing that we need to do when you're looking at an FBD. Label the net force, okay, as the potential motion or the actual motion of the object. Label that as positive, and everything else that goes with it positive, and everything that opposes it as negative. Always, yeah. At 45 degrees, the x and the y are always equal. Okay, so there is no vertical motion here. So Fn is equal to Fg, right? So we need to realize that. So that's pretty much it. So we can actually take a look at those blanks for now. It says Fg and Fn. We have to look for those. So let's go and figure out the Fg equals mg. So m is, do we know the mass? Mass is 5. And then multiply it by the g of 9.8, and that's gonna give you, let's keep the numbers here to 2 decimal place. What do you get? 49? Okay, yes, so just 49 here. So what does that mean? That's Fg. So we solve for 1, 49 here. That also gives you the Fn, right? Okay, so that's done. Okay, so now we take a look at the applied force. Just mentioned the x and y. It's good that you realize that right away, because it's an angle of 45. That will save you one calculation there, right? So let's take a look at the x direction here. Okay, what do we have for the net force along the x? You have your FAX minus frictional force. Is that okay? Yeah. You know how the FAY? Actually, the Fn here will not be 49. I just realized that there is applied force there. I forgot. This object is being lifted a little bit. I'm going to go back to this one for a little bit here, okay? Your Fn is actually going to be something else here. It's not going to be 49. Can we take a look at the y component here? There's no vertical motion still. That's still correct, okay? But your Fn here is going to be something else. So this is at level, at no motion at level. So at an incline, this is at an inclined FA, not inclined, it's an angled FA. So your FA is angled. Let's take a look at the up. What are the forces heading up?
FAY. Yeah, FAY.
Mm-hmm. FAY? And what do we do with the Fn and Fay?
So would it be Fn minus Fay equals Fg?
Well, first let's take a look at these ones. What do we do? Do we add or subtract? These two. Why do we add them?
Because they're both going up.
Yeah, that's right. So Fay is going up. As you can see, this one right here. Let's go back. Take this slow. Fn is also going up. You're going to add those two. They're both going up, right? And this is balanced by what's going down? The Fg. Okay, now this part right here, okay, that's what's happening in the vertical motion. So if we're looking for Fn, actually, let's isolate Fn here. Can we get the Fn by itself? What do we have? Fg minus Fay. Okay, so we have the 49 degrees here at angled applied force. We need to subtract the Fay. And what is Fay? Fa, let's do your trigonometry here, sine theta. Okay, so let's put the numbers in now. 49 minus, what's the applied force? Look at your picture. Applied force is given as 15. You guys with me? 15 sine of, what's the angle? 45 degrees. Okay, so what do we have here? We got 49 minus 15 times sine of 4. I'm using a different calculator every time. So it's good to know what your calculator is doing for you. There you go. And what did you get?
38.4.
Okay, 38.4. Why is it less?
Because the Fay is doing some of the work.
That's right. You're lifting a little bit here, even though that Fay is not enough to lift it off the table. Okay, it is making it a little bit less Fn. Okay, so that's our Fn. Okay, now that you have your X net force right here, we are looking for the other ones that are missing. What is the net force again? See that right there? It's moving at constant speed. This is actually equal to 0, right? So what does that mean? If these are all equal to 0, what do we know about Fax and Ff? They should be equal then. Okay, so what's our Fax? Let's do our trigonometry back to vectors, unit 2. Fa cos theta equals, now frictional force. How do we find frictional force? Mu F of n, remember? Okay, let's figure out what we have here. Fa cos theta. Let's put in the numbers. So you got 15 cos of 45 equals mu. We don't have the mu, but do we know the F of n? We know the Fn is 38.4, right? Could you see that? We calculated Fn earlier. So in this case, we actually need to find the mu first. It all depends on what you are given, right? So we need to find the mu first. Okay, let's actually put all these in numbers now. Cos of 45 times 15. Make sure you're doing this with me, your own calculator. I got 10.61 equals 38.4 mu. So mu is equal to 10.61 divided by 38.4. And that will give us our mu. What do we have? What did you get? I got 0.276. Now, when you're dealing with small numbers like this, don't round it off to 0.3. Okay? If we can keep it to 3 decimal places, that would make it even more closer to accuracy. Because if you round this off to 0.3 right away, you still have one calculation to do, right? Your frictional force is going to be way off if we decide to round off too soon. Frictional force is mu F of n. Now, can we find that frictional force?
Well, isn't the frictional force equal to
Fax, that's right. Yeah. Yeah, I want to check though. Yeah, let's take a look here. Remember, this is, you're right, equal to Fax. let's double check that and plug in our number 0.276 times f of n, which is 38.4. Now, what should you get here?
10.6.
Okay, let's double check. You got 38.4 times 0.276, and you get 10.6. And that tells you everything works out. Your calculations are correct. So now we can complete our blank on the diagram here. So mu is 0.276, and this one is 10.6. Now, if you round it off that 0.276, you're not gonna get 10.6. Okay, so don't round off. I always suggest keep it to 3 decimal places if you can, unless it says round it off to whatever sig figs you have. Now, can we actually extend this to sig figs? Let's take a look at the final answers. How many sig figs should you have for all the forces? How many sig figs are given? Look at the original question here. It tells you, did we use the 4, by the way? Again, it's given there. Why?
To understand the acceleration and net forces.
Exactly, to understand that whenever you see constant speed, it doesn't matter how many numbers or what numbers you're given. Okay, that's not given, that's not going to be relevant. So 4, how many sig fig is 4? 1. So we're not gonna use that because we did not use that 4, right? So this one is 1. Did we use the 5? We did, yeah. So that's 1 sig fig. So if I were to say use final for your final answer, use significant figures, that's actually gonna be 1 sig fig in this case. Then you're gonna have 1 sig fig in the final answer, which then we'll round off to just 10. Yeah. Okay. But I will keep it to decimal, at least 1 decimal place for the final answer. Okay.